Hi, this is Anirudh Yadav from Networkers Home. Today's topic is going to be Eigrp configuration. So you must have learned Eigrp theory, now it's time for the practical. So let's see how we can implement Enhanced Interior Gateway Routing Protocol, which was Cisco proprietary protocol till 2013, and now it is an open standard protocol in lab. So this is the IP configuration which I have done. All the IP addresses are pre-configured, and this is the topology in which we are going to implement Eigrp. Each of the router is having a loopback interface with the address corresponding to the router number. So if the router number 1 is there, so the loopback address is 1.1.1.1/32. For router 2, it is 2.2.2.2/32, and so on. So let's start with the Eigrp configuration, which is pretty simple. So what you have to do is, we have to go to the router. Under the router, you have to start the Eigrp process. You can start the Eigrp process by giving the command router Eigrp followed by the autonomous system number. So you need to make sure that on all of the routers in the Eigrp domain, the autonomous system number matches. If the autonomous system number is not consistent throughout the routers, you cannot do Eigrp, because Eigrp is an interior gateway routing protocol. So that can only work within the routers which are part of the same autonomous system number. So I'm going to take an arbitrary autonomous system number, that is 10. Then you have to advertise the networks in Eigrp, and you have to start the Eigrp process on certain interfaces. So I'm going to start the Eigrp on interface 10.1.1.0 or on the interface which is having 10.1.1.0 subnet. So for that I'm going to give the wildcard mask. So this command is going to enable the Eigrp process on the interface whose IP starts from 10.1.1. Why 10.1.1.1? Because the wildcard mask which I have supplied is 0.0.0. It means match only the first 3 octets, ignore whatever there is in the 4th octet. So whichever interface or the router's interface is carrying the IP address 10.1.1 or whose IP address is starting from 10.1.1.1, on that interface Eigrp is going to get started. Second thing, apart from that, Eigrp is going to advertise the network which that interface is carrying throughout the Eigrp routing domain. So wildcard mask in Eigrp is totally optional. So what happens is Eigrp first forms the neighborship. Once it forms the neighborship, then it creates something called as Eigrp Topology Table, and from the topology table it chooses the best part to each and every destination or each and every network, and that part is inserted in the router or in the routing table. So I've advertised one directly connected network. Now it's time to advertise the second directly connected network. The network is going to be 1.1.1.1 followed by 0.0.0.0. So I've advertised both directly connected networks in the Eigrp domain. Now let me go to router number 2. Let me do the same thing. So all I have to do is I have to go under router Eigrp 10. That was some typing mistake. And so I'm in the router Eigrp process of AS number 10. Now I have to say network of 10.1.1.0. I can just skip giving the wildcard mask. But if I skip giving the wildcard mask, see what is going to happen. I've given the command 10.1.1.0, but how the router is going to interpret this command? The router is going to interpret this command as 10.0.0.0. So it is essentially going to start the Eigrp process on all the interfaces which are having their IP address starting from 10, rather starting from 10.1.1. Alright, so you can either skip giving the wildcard mask, because right now we do not have any subnets of 10 here, so we can safely skip giving the wildcard mask. Also we have a network of 2.2.2.2 directly connected and a network of 20.1.1.0. Since we are not using any subnet of 1020, but what we are using is the full networks, so we don't need to worry about that now. And I'll skip. Then we'll go to router number 3. We'll do the same thing for router number 3. We'll go under the Eigrp configuration mode. We'll advertise the directly connected networks. The moment I advertise the directly connected networks, you see the neighborship on that particular interface comes up. So Eigrp convergence is very fast, as you can see. Next we have to say network of 30.1.1.0 followed by the subnet mask, so that it only starts on the exact interface and network of 3.3.3.3.0.0.0.0. Similarly, we have to do this configuration on router number 4. The configuration is going to be the same. We will say router EIGRP 10 followed by network of 30.1.1.0 0.0.0.255, and you will notice the moment you give this command, neighborship will come up. It is not coming up, it means there is some problem. We'll troubleshoot that problem. Network of 4.4.4.4 0.0.0.0. Now let's see what the problem is. If I check now, show IP protocol. So it is advertising for network of 30.110/24 and everything seems fine, and this is EIGRP 10. Let me check the same settings on router number 3. Router number 3, do show IP protocols. Again EIGRP 10 is there. It is advertising for, so as you can see on the screen, it is not advertising for 30.110, rather it is doing for 3.1.1.1, and which is not quite our network. So again we'll correct this under the router configuration. We'll say no network of 3.1.1.1 0.0.0.0.255, rather network of 30.1.1.0 0.0.0.0.255. Now you see, after fixing the problem, the neighborship came up. So now let's go to router 1 and let's check the routing table of router 1. Show IP route. So as you can see, all the routes which are marked with D are the routes which are learned by EIGRP. Since EIGRP uses an algorithm called as diffusing update algorithm, also known as dual algorithm, all the routes learned via EIGRP is marked with D. You also know that the administrative distance of EIGRP is 90. So all the routes of EIGRP will have 90 as their AD value in the routing table. The next field after the slash is the metric of EIGRP, which by default utilizes bandwidth and delay. It uses bandwidth and delay to calculate the metric. Higher the bandwidth, lower the metric, higher the delay, higher the metric. So what we prefer is higher bandwidth, lower delay. Whichever route is having the lowest metric goes into the routing table. You can check the neighbors of EIGRP by giving the command show IP EIGRP neighbors. So as you can see, it only has one neighbor which is connected to Gigabit Ethernet 0/0. The IP address of neighbor is 10.1.1.2, and these are certain timers and other parameters. You can check the topology table by giving the command show IP EIGRP topology. So as you can see on the screen, all these routes are learned in the topology table, as you can see, and this distance is called as feasible distance, followed by the reported or advertised distance. Now it might happen that one router is having multiple paths to one particular destination or to one particular network. So whichever path will have the lowest feasible distance will go into the routing table, which is called as successor. So let's check the routing table. So all these routes are successors because they all are having the least feasible distance. Right now, because all these routes are the only possible routes or only available paths, so they all become the successors. So that is how you check the parameters regarding EIGRP. Now EIGRP again uses something called as hello and hold down timer. Hello timer for EIGRP is by default 5 seconds and hold down timer is by default 15 seconds. So you can change all the timers simply by going to the interfaces. You can go under the interface Gigabit Ethernet 0/0. You can say IP EIGRP, or I think that command is not supported in this packet tracer software, but the command is IP hello timer, IP EIGRP hello timer, or IP hello timer EIGRP, followed by the timer which you want to give. So that's all about EIGRP. Thank you.